Hi, I'm Natasha, and I will be going over the ANSYS fluent flow. You won't be able to see this part, but I did open the fluent flow already, and I'm going to share my screen. Fluent flow, share, and this will pop up. So once you open it, if I can, you can find it on your either your desktop or wherever you saved the ANSYS fluent, which is the simulator we'll be using. So what we want to do is we want to select the step flow 2. It's in my recent files, but if it's not in your recent files, you want to go read, mesh, and find it. So I'm going to select mesh, and then we're going to start. So this will open up. And then I'm going to share again. All right, so now that the ANSYS step flow has been opened up, it will load. Okay, so now it's loaded in. You can see you don't see any mesh or geometry, and that means that's because we have to actually display it. So you can either go up to the domain and display, or you can simply right-click in the user window, right-click, display mesh, and then the mesh will pop up. You want to make sure faces and the inlet, outlet, and wall are selected. Display, and it'll pop up here. Then you can close. So something I don't like is the shadow, so I will go over here on the right and deselect it. You can also deselect this grid, but I like to see the grid, so I leave it. So the first thing we want to do before we do any results is we want to change this units of this geometry from meters to millimeters. So you want to go to domain, mesh, scale. And then you can see it's 0, 0, 0, 150, 10, 10. But we want to make this millimeters. So you're going to go millimeters. But you can see we don't want these values. We want 150, 10, 10, like we had before. So why did it change the values? It's because it doesn't have the scaling system. So what we need to do is convert units, select millimeters, and scale. And now it's scaled. So now you can close. And the next thing we're going to do is a boundary condition. So you're going to go on this list over here on the left, and you're going to find the boundary condition, which is under this setup here, and click the arrow to the left. And now it will pop up its list, and you want to select the arrow to the inlet, and then the inlet, the velocity. And then double click the inlet velocity. Right? So that will pop up. And now we want to change this velocity magnitude to 2 and apply. So now we can close that. And now we want to initialize the solution. So you want to go under solutions. That's over here. And then go all the way down to initialization. So you're going to press initialization. And then you want to make sure that it's a standard initialization. Compute from all zones. And then initialize. Right? And now we're going to review the results. So under this initialization, you will find a calculation activities, and then you're going to right-click, double-click run calculation. So this will pop up. The only thing we're going to change here is the iterations with 200. And then you're going to calculate the results. So it'll take a few seconds to calculate. Right, so now the calculation is complete and you can press OK. So now you have ran the calculation. So what we want to do next is create the ISO surface. So you're going to go up here to the domain, results. You're going to go to surface, create, find ISO surface. From here, the ISO surface menu will pop up. We want to change the name from Z equals 5 or Z2. We're going to change it to Z equals to 5. And then your surface is of constant. We want to make that mesh. And we don't want this onto X coordinate. We want to make it to the Z coordinate. Then you're going to compute and it should be 0 to 10. And under the ISO values, we want to make this 5. I usually just select the number and then on my keyboard press, but you can also use these arrows. And then you want to make sure that, you can see all of these and then create. So now you can see in the outlet wall, NZ equals 5. So now you can close it. So the ISO surface has been created. All right, so now we want to visualize the pressure. In order to visualize the pressure, go back to that results tab, go to these graphics, and you want to go to contours. New. And what will pop up is pressure already selected. And we want to go Z to 5. And then we want to display. And as you can see, nothing came up, but it's not, the geometry has just gotten lost in the results. So what we want to do is we want to select this. And now it has popped up. So you have the scaled residuals, contour pressure. And now you have your results. Usually you can just, you can do a couple things. You can just scroll with your mouse. That's easier. And then you have last view, this view. Zoom in and out. You can move this. The find button. All sorts of things. Then let's go put that back. All right, so next we are going to do the velocity. So you're going to go to pressure, velocity, and then save. So now you see the velocity. So you don't have to change, you don't have to go out of this menu to do pressure and velocity, but you can also do turbulence properties and a bunch of other things within this menu of contours. So the next thing we are going to do is we are going to do relative location. But relative location and visualizing the vectors. So we are going to close this. We're going to go to results. And then we are going to go to vectors, new. Now the vectors will be popped up. And now we want to go select the Z5 and save and display. So now it has popped up, but it's really busy and that doesn't look nice. So what we're going to do is we are going to skip by 10 and we are going to save and display. So now it is easier to see it, but it's really small. So how are we going to do that? We are going to scale by 5. And now, even though it looks busier, it's a lot better visually to see. So that is how you see the velocity. Or see the velocity vectors as we are doing velocity, but you can also look at relative velocity as well. And then now we want to do is the relative location. So you want to go to this options, draw mesh, and now the mesh will pop up. want to deselect the faces, select the edges, outline, and then make sure Z equals 5 is selected and display. But this is really hard to see. So how are we going to make this, or see it better? Well, you want to go into this menu again, this mesh display, and you want to go colors. Now the colors will pop up. So you want to make sure that the wall is selected and that you pick a color that you visually like to see. I am going to choose black. And I'm going to close and display. So now it's displayed. And then I'm going to close that. And now I'm going to save this. And now we can see the velocity vectors within the relative location. So the last thing we want to do is the streamline. So where we want to go is I'm going to close this. We want to go to results, graphics, path lines, new. So now we want to select Z equals 5, select the draw mesh, display, close, and then we want to make this skip by 50. As visually it won't look great. So save and display. And now it looks really good, but if we were to have that not skip at all, which will take a little bit, that looks really busy and you can't really see what's going on. So skipping by 50, you get these results and you can understand what the data you're looking at. We're gonna close, and that's all we are doing today. So thank you, and I hope you have a great